Hi again, I hope you're all enjoying the summit. I'm going to talk right now how we made Scylla scan 1 trillion. That's the next challenge, not yet. That's maybe for next year. Instead, let's take performance for granted. We all know how performant Scylla can be. What I'll be talking about is how to be successful with Scylla. This is data that those are things that I see in the field all the time, questions that some of you had asked me. So what I decided to do this year is just come up with a compilation, an FAQ of sorts, things that we hear all the time. This is your guide to best practices on a general level on how to do Scylla correctly, the best way possible. Once more, this is me. I'm VP of Field Engineering, so I interact with a lot of you. It's been a pleasure so far, and I hope this relationship to continue for much, much longer. So let's start by talking about your first, and like when you're just getting started. One of the things that we take very seriously is compatibility, initially with Cassandra, and now, as you were seeing, we're adding more APIs, we're adding more to that. So one of the ideas is that you shouldn't have to learn that stuff, but that is a double-edged sword. Things to remember when you come from other databases. Data model is the same. So how I summarize this is that remember what you learned from Cassandra, if you're coming from Cassandra, about data model. But whatever you know about operations, just think through it again. Because what we see a lot of times is people doing things in Cassandra, not because that's the best thing to do, but just because you had to do this to work around the problem, or like you had to put a cache here because the read performance wasn't great, or you didn't compact your data often enough because it would take, as I heard from a customer once, you're asking me to do in their use case like a major compaction every day. How am I supposed to do something daily that takes 3 days to run? I said, well, try it, and it took 2 hours. So yeah, something that takes 2 hours you can't do daily. So in general, like data model is something that it's going to be about the same, but try to reevaluate if you have an operational procedure, even though the way you do it is the same. I mean, should I still do this procedure? And obviously we're there to help you if you need any guidance with that. A corollary of this is how you compare those databases. So if this is like even before you start, if you're doing a comparison, yeah, certainly you can try to do a comparison like using exactly the same hardware, exactly the same data model, everything exactly, and that does tell you something that is good information. I'm not going to say you should never do that, but there are also the fact that those different databases will perform differently in different scenarios. They're going to have their strengths and weaknesses. So the way I like to approach this problem better is like, here is my problem, and if at all possible, let me take a step back and try to, reevaluate. Am I doing the things playing to the strengths of those databases instead of just doing it because I was doing it before? Some general useful advice. This is for everybody. Like monitor your clusters. We hear this all the time. Like I'm having an issue, and then you describe the issue to me, and you expect an answer like what could go wrong, and my first question is always like, are you monitoring your cluster? The answer is no. Please start doing this. And sometimes you don't even need my help anymore because we invest a lot of time and effort into making sure that the Scylla monitor has a lot of information, that this information is readily available and it's easy to consume. A lot of your bottlenecks, a lot of the things like what could my bottleneck be, just by looking at the graphs you're going to be able to see. So running your cluster without monitoring is the most sure way to fail. Just don't do it. Also, try to keep your versions up to date. Do upgrades often, and we understand and realize that, we don't necessarily want to upgrade often. There is such a thing as like, maybe I want to be conservative. I am okay with that. So there are situations in which you want to move faster. There are situations in which you want to move slower. But if you move too slow and you get too far behind, at that point you are in a version that is no longer supported. So if there is a problem, and problems every now and then they do pop up, you're not going to get a patch for that. So our policy is usually 2 versions. So if you are an open source, that's 3.0. Right now it's 3.1 and 3.0. That means if you are on 2.3, you are an unsupported version. And enterprise versions follow the same, exactly the same idea. Their cycles are much longer, so you're going to have to upgrade less often, but do upgrade. So for instance, if you are using Scylla Enterprise 2017, you're not actually in a supported version. If you do have a problem, you're not going to have a patch. Running the previous version is okay. As I said, it's a conservative thing to do. You allow other people who have a higher risk tolerance to find the issues first, but don't run too old. And try to keep the patch levels up to date. The patch levels we also put a lot of effort into making sure that they are very low risk. So if you're using 3.1, we just released, for example, 3.1.1, try to be always in the latest patch level. Now, where to run it? There are many, you can make the choice of should I run it in this cloud, in that cloud? Should I run it bare metal? Should I run it here? Essentially, as I said, you can run it anywhere, but the choice of hardware can make a lot of difference. It can matter a lot. One of the things for you to keep in mind is that where are your bottlenecks coming from? I mean, are you bottlenecked by the CPU or are you bottlenecked by the storage, both in terms of sizing or in terms of speed? If you are bottlenecked by the storage, especially storage size, try to go with a larger instance. We have, for instance, AWS just announced last year or earlier this year, I can't remember, instances with 60 terabytes of data. They have fewer cores per terabyte, but if that is what you need, that is a better choice than trying to squeeze in into an instance of a different type. HDDs in general, I mean, I usually don't recommend. Some people do have them, and we try to make the best out of it. But SSDs are getting cheaper and cheaper and cheaper by the day, so it's a much, much better bet for you to go on SSDs. And if you need the latencies, then NVMEs are essentially a better option. For throughput, you can still put a lot of SSDs together on a RAID array, and you're going to get good throughput. But the latencies coming from an NVMe are much better. So our recommendation is always like, if you can't, go with it. And networking, in general, just forget gigabit networks. They're definitely not fast enough. We see a lot of problems from people still insisting maybe 1 gigabit a second is enough. It's not. You're going to start having issues. Obviously, if you're on the cloud, that's not that important. But if you manage your own on-prem deployments, pay attention to that as well. Now, storage layout, how to best organize many disks. There are various valid use cases in which you don't want to follow this advice, but the advice is still like try to use RAID 0 and not a higher RAID setup. And the reason we have this advice, I just want to talk about reasoning so it doesn't feel like just an empty advice, is that Scylla is already replicated. And it is designed in a way that if you lose a node, you can replace that node plenty fast. So why would you have, and as I said, there are valid use cases, but in the general case, why would you have a replicated array of disks that if you lose a disk, you can just replace the entire node. It should be fast enough, and that gives you speed back. So you actually get your day-to-day faster because your disks are faster, your arrays faster, and the rare event of losing a disk, you can just replace the entire node. Splitting commit log and data, it's also something question that we hear a lot. I mean, should I buy a new disk, fast disk, just for commit log? My answer is usually no. You don't have to go and spend the money or whatever, like attach a different disk just to do that. We have the schedulers in Scylla. It's part of our foundation. It's part of what we do. That you are very good at isolating the workload, but if you happen to have, because you bought the hardware this way and it doesn't change the pricing, or you got a promo or whatever, you happen to have a fast disk for commit log, then you can dedicate that volume just for commit log. But I wouldn't go out of my way to actually get something just for this purpose. In terms of hardware sizing, I'm not going to spend too much time on how to actually size it because we have a presentation from our VP of Solutions, Eyal, just about that. So attend the presentation if you're interested. But I will highlight one fact, which is a lot of times we see people sizing the hardware as if you were going on a trip in which you plan to spend $1,000 and then you take with you $1,000. Like if you've ever done it, you know you're not doing it again. Because what happens is that you had an expense that you weren't really counting on, and then where's your money? I run out of money. So when you go on a trip, you always take extra because you know that something is going to happen. You don't know what, but you know that something is going to happen, so you prepare and leave some spare. So my advice in terms of sizing is to do that too. Take into account that you're going to lose a node, that you're going to maybe have to do some manual operation and transfer data, copy data. So leaving some spare on the disk is good as well. So you're going to have more leeway to deal with issues as they happen. It's rare that they happen, but when they do happen, you want to have the spare to actually make sure that you can handle it without affecting your production. You do that by having spare. How you combine this hardware. So again, we hear this question again and again. Should I use a lot of small nodes or should I use fewer, bigger nodes? So in which situations should I use more smaller nodes? Never. And again, we have a white we have a white paper about that. We've done webinars in the past. We had experiments to show that their usual concerns is that, well, but if I lose a node, then it's more expensive to replace it. It really isn't. We have data to back it up. I mean, if you have more data in the same node, sure, it gets more expensive to replace that node. But if you double the data set, but also double the power of the node, this is essentially constant. It's what we see in the graph. So, I mean, if you plan to double your data set, consider doubling the size of your nodes first. I mean, try to run, because it's more, operationally, it's much easier to handle things that are just fewer entities. If you have to do like a kernel upgrade or etc., it's just easier to do it on fewer machines. However, or just don't kill me. I have to tell people like how it really is. There is one situation in which I'm okay if you're going to run smaller nodes. And what is that situation? When your cluster is small enough, right, so that when you are expanding, you don't necessarily want to double. So in our example here, you have 32 cores, and then I want to expand it. So that I have like 32 cores total, and I want to expand it. So for me to expand it, because I want my nodes to be the same size, I am forced to go to 64 cores total, unless I go heterogeneous, which isn't great. So that's why in this situation, it's actually okay to try to run smaller nodes, because when I expand, for instance, if I'm packing this on 16 cores, I can add a new machine with 16 cores, and that takes me to a total of 48 cores. But as soon as you get big enough, I mean, as soon as you start having, like I'm having 3 nodes of the biggest possible, and I'm okay, which is actually, again, recommended, I'm okay doubling the size, then try to pack it in as fewer machines as possible. But if you have this concern, what about my first expansion? That is a use case in which it would be okay for you to try. Don't go like a bunch of 4 cores, but maybe take it down a notch. It's a valid concern to have. Now, configuration. How should I configure my Scylla boxes to take the most out of it? Usually, this is something that shouldn't be of a lot of concern. You just run the Scylla setup. The Scylla setup will configure everything for you. We also, as I said, invest a lot into making sure that Scylla is essentially as close as zero conf as possible. But there are things that we still see people getting wrong every now and then. Scylla setup is an interactive program. So it will sometimes ask you questions, and you're going to say, well, yes or no. So I want to expand a little bit on which questions are really important that you say yes to, or at least understand what is the impact of saying no. And also it goes deeper than that. When I'm talking about configuration, I'm also talking about like how to configure your racks, how to configure your topology, and etc. So how to essentially get the Scylla cluster ready to go. So let's talk about racks first. So I have my nodes, and they live in the same data center, but I want to take a look at how do I configure them? How do I place them in different racks? General advice, have as many racks as you have replicas. So if you're running on a replication factor of 3, which is the most common setup that we see, run it in 3 racks. Simple as that. So if you're on the cloud, you're talking here about availability zones. Can you deviate with that? Sure, but like this is, I'm going to show you like what are some of the side effects of doing that. Why do we give you this advice? Because Scylla tries to place a full copy of the data into each rack. So if you configure your cluster to be multi-rack and you have 3 replicas in 3 racks, I will guarantee to you that you have a full copy in each rack. So if you lose the rack, you lost the copy, but just the copy, right? This is what happens, right? So if you're doing quorum reads and writes, you're not going to even notice. If you lost the full rack exploded, like it was a nuclear war or something like that, and you lost an entire rack, you don't notice. Well, you might notice the nuclear fallout in that case, but you're not going to notice that their database is having any issues. Your queries are maintained. You haven't really lost any data. There is no situation here in which there was data that was there and is no longer. It's just no problem. So this is how it should be. However, if you have 3 replicas in 2 racks, can I do it? Sure, yeah, you can do it. But what happens is I'm going to put my first replica in one of the racks. I'm going to put my second replica in the other rack. And then the third replica, since there isn't a third rack, I just have to put in one of them. And then what happens? If I am lucky, and I lose the rack on top, I lost the replica, and I'm cool with that. My quorums are maintained, nothing happens, I didn't lose any data. But if this morning I was walking down the street and I happened to see a black cat and it was Friday the 13th, or if I just exist, because let's face it and let's be honest, this is more likely a scenario. Usually being lucky is the exception, is not the norm. What's going to happen is that you're going to lose the rack in which you had 2 copies. And I can actually guarantee you that this is what's going to happen, because situation in practice is not like there is this one rack that is going to be hosting 2 copies. Part of your keys are going to be in this rack, the other part of so you're going to lose something, right? This is guaranteed to happen. And you just might have lost your job. So depending exactly on your consistency guarantees. So I mean, this isn't something, this is one of the things we've heard recently from a customer, like if I lose this cluster, I lost my job, and they had everything in a single rack. And I said, I hope you don't like your job too much then, because that just might happen. And obviously we work with them, like how to make this now into a 3-rack situation. I happen to like the guy very much. I wouldn't like to see him fired. And it can happen. Like if this is this mission critical, there are some clusters who are not mission critical. You can lose the data, it's fine. And for cost reasons, you might want to put it in a single rack, then there is really not much reason to do it in 2 racks in that case. Even single rack is a valid use case for those situations in which you're fine in case Google or AWS or Microsoft just lose an entire rack. Otherwise, just keep those things matching. To actually make that work, you have to choose network topology. Moving from simple strategy to network topology is a major pain. So my recommendation, always use network topology, even if you're not on even if you're in a single rack, because it will make your life easier later to make those changes, right? So use network topology all the time. This is what tells, if you're not using network topology, you can have as many racks as you want, but that tells Scylla, I don't care about placement. Network topology is how you tell Scylla, I care about placement. And then you're going to place your copies in the right racks. And then obviously when expanding the cluster, if you are on a single rack, you can put just 1 node. But if you are on 3 racks, you want to put 3 more nodes, because you want to keep those racks balanced. Right? Otherwise, again, remember, we're going to put a full copy in each rack. So if you have imbalance there, you're going to end up with imbalance in the sizing of your nodes. And do run, as I said, do run the setup tool. But if I had to pick one thing, I didn't have to, I could have picked a lot of things, but just to highlight it and enhance it, if I had to pick one thing that people keep doing it wrong, and I could tell an audience, just pay attention to that, which happily I can because I'm here on stage, which is configure your network. What does that do? I'll explain what exactly it does, and it will become clear why this is important. When Scylla Setup asks you, do you want to configure your network interface? What it does is it pins the interrupts in which the CPUs in which the interrupts are going to be delivered. We do pinning of this interrupt according to your hardware. So there are 2 major ways in which we do it. If you don't do this, what ends up happening is that the operating system will unfairly deliver interrupts to a couple of CPUs. It doesn't have to be one, but maybe there are 3, 4, 5 CPUs out of your 30 that will get most of the interrupts. Those CPUs are running Scylla as well. Again, because you said don't tune it. You said don't do anything with it. So those CPUs that are hosting a part of your data, they're going to start to get slower to serve your queries because they are busy serving the network interrupts for all of your machine. When you say yes to this question, when you say, yes, I do want to tune my network interface, what we are going to do is that we're going to look at your hardware and make a decision to use one of those two modes. One of them, I will isolate one or two CPUs. So it also depends on your hardware, but I might isolate one, I might isolate two CPUs just to handle your interrupts. And if you do have enough hardware queues and a lot of other things happen as well, I might decide I will put all of this in the first case, of course, Scylla will not be running in that CPU, right? So the interrupts are all going there, but Scylla is not running there. In the other scenario, I will still run Scylla in all of the CPUs, but I will make sure that all of the CPUs are getting interrupts, and all of the CPUs are getting interrupts fairly. So yes, they all pay a price, but they all pay around the same price. We decide that based on the number of network queues that you have. Very, very, very common. People say no to this question because it doesn't sound like important. We actually have been trying to convey this importance in the message more and more. But if you don't do it, you end up in the scenario over here. One of your CPUs is going to pay for that. Yeah, another one that we actually, we want to put it in the setup tool soon. This is actually a problem we've just discovered, your clock source. But until we do, I mean, you might want to check that out too. What is your clock source? Your clock source has nothing to do with NTP or timekeeping of wall clocks. It just means what physical device do I use to produce information about what is the current time, to essentially do timestamps. Scylla is a very timestamp heavy application. So you can have a variety of choices of which device to use. The fastest one is just your processor TSC, which is essentially every time it gives you, like, it used to be a cycle counter, I'm not going there, but this is the fastest one available. If you're running on AWS, for instance, on the older i3 machines, you might be using the Zen, from the Zen hypervisor, the Zen clock source. Just for you to have any idea, if we measure how long does it take to get a timestamp from each of those clock sources, if you're taking it from the TSC, it takes around 25 nanoseconds. If you're taking it from the Zen clock source, it's going to take around 100 nanoseconds. So what that means is that every time you go there and you have to take a timestamp, which we do all the time, you're going to get 4 times slower. We're going to integrate that soon into the setup utility, but for the time being, you might want to check that out. All right. Now let's talk a little bit about data. How should I model the data, partition the data, look at the data in order to maximize your success? One thing, if you're not doing it, most of you are. This is something that we don't see often, but every now and then we do see it. If you have to learn something from this presentation, prepare statements. There's no excuse not to do it. The only situation in which it's okay not to prepare statements is that this is a SQL query that I just decided to run and I'm never going to run it again. It's fine. I mean, you're doing it from the shell just for some ad hoc stuff. But if you have queries that are running periodically, it doesn't matter if you're running them once a second or 100 times more or a million or a billion or a trillion, it doesn't matter. If you're doing something periodically, prepare those queries. The impact of not preparing, it's visible. Like a lot of times you see, oh, my CPU is bottleneck and I'm only doing really 100 queries a second. Not prepared. It impacts your latency, impacts your throughput, impacts essentially everything. Partition sizing. We get this question a lot, how big can my partitions be? They're almost not a problem anymore. Like it's still, like we inherited some of it from Cassandra. It used to be the case that I have large partitions, that's the end of the world. We got much better over the years. Now in Scylla 3.1, even our repairs are now able to operate on a row level, which means inside the partition. So big partitions aren't anymore the problem that they used to be. But there's still one problem that really comes from large partitions. So what I would say is that, is this a problem? Really depends on your query. If you look at those queries that we have as an example, the first query isn't really that much of a problem. Again, so it used to be the case that if it doesn't matter what my queries are, large partitions are a problem. The first query is essentially, out of this partition, give me one row. Now, we got pretty efficient at that. This is essentially almost a problem solved. As I said, there are still some edges to smooth here and there, but not too much of a concern. The real problem comes if your query looks like the second one, like give me the entire partition. And why is that? Because as your partition grows, the time to actually complete that query grows as well. So if you tell me I'm doing 2,000 queries a second and there's this one shard that doesn't seem to be able to handle, it bottlenecks. Why? Because in my query, I want to look at the entire partition. So obviously, this is going to be more expensive than the others. Just pay attention to that. Large partitions going wide. Our record, I think, is a partition with 130 gigs. So see, this is pretty impressive. The customer who had that didn't even notice until, of course, they did. It's at some point to do. But the reason they noticed was exactly because they started doing queries like the second one. So out of a sudden, hey, why are my queries taking however many seconds to complete? Well, because your partition is 130 gigabytes. So you got to move that out. Bad distribution is not a unique Scylla issue. What is bad distribution is essentially when you query some partitions more than others. But in Scylla, you tend to see this issue sooner. Why? Because if you come, this is especially for the folks coming from Cassandra. Cassandra shards things at the node level. So if you have a hot partition, you might not even notice it because the entire node is handling it. So maybe if you have 100 nodes, you will notice. But maybe you started with 3 and replication factor of 3. So you don't really, it's impossible to have a hot partition issue. You don't notice. Again, the problem doesn't start because you're using Scylla, but you're going to see it right away because we're sharding at the CPU level. So you're going to start to see a CPU that is essentially bottlenecking. Now, if you ask me, this is actually a good thing. It's showing you the problems with your data model sooner. You want to find those problems as soon as possible. But pay attention to that as well. It's important to have a partition key with very high cardinality. It's important to have a partition key for which you have a lot of values so they can distribute well. And also make sure that your traffic, maybe you have 1 billion partition keys, but you decide to query just one, you're gonna find those issues. And Scylla is gonna show you this like very, very early in the process. Other hint on how to be successful with Scylla, keep track of our blogs. We always getting this information out, and whenever we find them, we find this usually in customer sites, but we want to make sure that the entire community is benefiting from it. So this is just one recent one that got out of one of those experiments, and like understand how the cache works. You don't really have to understand how the cache works to use the database, but obviously if you do, it's going to give you an edge. So one example that comes from this blog that I would like to highlight is our cache is essentially an all-RU. And what that means is that when the row was touched determines which rows I'm going to discard. When you're doing range queries, one of the interesting patterns, and I'll invite you to look at the blog, if you're doing a range query in which you're always specifying the current time as whatever system.now that you have in your system, the way the cache works is that it tries to cache ranges that you queried before. We can cache infinite ranges, but if you're asking for a specific time point, I'm caching just what you ask for. So the next time you ask for, now, but now is 2 microseconds in the future, I don't have this last piece of information in the cache. I need to go to storage again to fetch it. So if you have patterns like this, try to do like a scan without an end. If you just say, give me all, so if you have a time series data access pattern, it's better to say, give me all rows starting from this point of time instead of bounding both sides. If the right side of your boundary is always moving. Lastly, parallelism. Parallelism is important. A lot of times we see people not bottlenecking their Scylla boxes because they don't have enough parallelism. So we thrive on it. Throw us parallelism. However, there is such thing as too much. Right? So infinite parallelism is asking for trouble because at some point the cluster is not going to be able to handle it. And when I'm saying infinite here, I don't mean the mathematical concept of infinity. Like we've heard before, like we have limited parallelism. We have this controller, this thread pool, etc. that guarantees that at most, at any given time, it can only be sending 4 read and requests to the database. That's essentially infinite. So when we say finite, it just means like a boundary that makes sense. There are ways, we're actually about to publish an article very soon, so I'm not going to go into details. There are actually theoretical ways in which try to, based on your throughput requirements and your latency requirements, what is a good concurrency. And also be careful with retries. A lot of times we see people, hey, my requests are timing out, and then I'm retrying, and my server times it out in 10 seconds, but my client times it out in 1 second. So I just retry it again because maybe it will be successful this time. It won't be, because what happens in this situation is that by throwing more requests, you're actually increasing the parallelism even further. If your timeout happened just because you were unlucky and you had a network glitch, that's fine. Otherwise, you're just adding to the trouble. Batching rights, finally, just to finish. Should I batch? Usually no. It's fine to batch the same things that go to the same key. But usually when you batch things that go to different keys, that's usually not a good pattern. This is the same as Cassandra, and it's just because you're not going to be able to hit the node that has the data. I don't think we're going to have time for questions, but I'm outside. I'm always happy to talk about those best practices. Thank you very much.